Hello. I've just come out to the shop and I'm decided that I'm ready to do a continuation of the two videos that I did yesterday regarding the problem I had with the machine stalling on a very small cut. And I couldn't understand why it would do that. I had it on the lowest speed and I changed the belts over to the smallest pulley and the largest pulley on the head. Originally I had it on the middle pulley on the motor and the middle pulley on the headstock, and that's when I was having problems with a torque taking a cut on even smaller diameter stuff than this. I couldn't understand why it would keep on stalling. The motor would drop 400 RPM and I didn't have it running. I had maybe running at 1200 and it would drop right the way down to 800, and even if I kept my hand on the wheel tightly, it would stall the machine. So I've been experimenting, as you will see in the previous videos, and I'm getting better results from this setup here with the drive pulley. At the moment I've got it running at, it says 687 here, so I would say it's about 700 RPM, somewhere in that region. It fluctuates a bit. Last night I took a sample cut of 60 thou, and that turned out okay. No chattering, nice finish. I had resharpened the tool bit, so that helped. So now I'm in the process of taking an 80 thou cut, and I'm going to proceed now and give you a little insight. I really would like to solve this problem, because it can take, if you're only taking 20 thou cuts and you've got quite a bit to take off, then it can take quite a while, especially when you're on slow feed on the carriage as well. So I just wanted to get this solved, this problem solved. I think I'm going to convert over to a tooth belt and make up some new pulleys, or purchase some new pulleys and modify it later on. I still have the adapter for the versatile dividing head and the take chucks that I have to finish off. So but at the moment I'll get this sorted here, or get the best result I can, and see what happens. So okay, I'm going to take an 80 thou cut and see how it goes. It's dropped right down to 600. Now this steel, it's a hot rolled, I'm pretty sure of that. The specifications I'm not so sure of. It's a piece of stuff that I had in a junk box that I obtained when I left my last job, and there's a little bit of vibration taking place. You can probably hear that. It's down to 590, 580, fluctuating a bit, but overall it's doing quite a nice job. The full size of the shaft is 1.450, so I imagine that I'm getting down to about 1.1 diameter at the moment. But as you can see, I'm getting a very nice finish. The cuttings are coming off stringy a little bit, but not too bad. I'm gonna put another cut on now. I think I'll try a 90 thou total. Okay. Where are we? It's a nice finish. Pretty good anyway. There's no nasty like digging lines like you sometimes get with rough mould steel, some kind of a unknown quality of steel, where you get like a rough, groovy finish. It's nice and smooth, and that's probably because it's hot rolled anyway. I think hot rolled machines a little bit better than cold rolled, unless it's free cutting. Okay, I'm going to take 100 now and see what happens. The reason why the tailstock was, or the revolving centre was becoming loose, was when I was taking a cut before and getting lots of chatter, it was actually pushing this headstock back on the bed. So I nipped the clamping screw up a little bit tighter, and that seems to have solved that problem, unless of course it chatters again, and then maybe it will start moving again. I just want to add that when I'm normally machining, I very rarely go over 1500 RPM when I'm machining anything really, stainless steel. Probably I might run about 600 or 700 RPM when I'm cutting 403 or 304 I should say. So this is not normal practice for me with this high RPM. I'm trying to establish what's going on between the motor and the control box, and the amount of torque that I'm getting, or the lack of torque that I'm getting when I was taking a small cut. I'd even start drilling maybe or I don't know what, 1/4 inch drill bit, and if I put too much pressure on, it would stall the chuck and the job. So I don't really have a lot of experience with motors, DC. It's all a little bit phasey for me, so that's some of the reason yesterday I noticed in somebody in the video that I was running it at 1200 RPM and taking a cut along here, and it was not cutting very well. Well, it was because of the tool bit. I mean, the tool bit was getting blunt. It was running too fast. I realised that, but this was all because I'm trying to find out what's going on between the motor, the control, and the feed, the cut, the depth of cut. If I took a 20 or 30 thou cut, the motor would stall, or I presume the motor was stalling. It could have been spinning, and this could have been just locked up. So this is not my normal. I just want you to know this is not my normal practice of running at high speeds and blunt tools and stuff like that. So okay, I'll take another cut on this section here. Of course, it's hanging out quite a way. It's got support here at the tailstock, but it's still hanging out quite a bit from the main bearings of the headstock. So it's just a small lathe. Okay, I took 80 before. I'm going to take 90. 10, 20, 30, 40, 50, 60, 80, 90. I might drop the speed a bit. That's at 680, 690. That's running around 700. I'll drop it down to, that's 590. Give that a try, see what happens. So that's a 90 thou cut. Well, it's 90 thou off the diameter, so it's 45 decimal cut. And that's 90, so I'm getting a little bit of vibration and chatter, but it's certainly an improvement to my experience before all of this. So I definitely had, I think I come to the conclusion that I had the belt on the pulley that was not really right for this size motor, and plus the control box. I'm sure this control box, I had a dart control box before on a half-inch DC motor, which was quite large on here, so I got rid of it and bought this instead, thinking it would fit in nicely with the size of the lathe. Now that's not bad, it's 90 thou. Anyway, I had this dart control before, and that worked really good. But of course it was a half horsepower motor as well. Great big thing it was, really. Maybe I should have kept it, but I think eventually I'll get something sorted out here. So that's dropped down to 4,500 from 600. So it wouldn't take much to stall it, I'm sure. Let's see what happens now. Now that's a 60, a 80 and a 90 thou cut that I was trying to take there when I contacted the shoulder. So that's a 100 and it wanted to stall. But let's see, that's 90, it's 190 and 80, 170 thou off the diameter. It's too much. I mean, that's quite a... But the headstock didn't move back. Let's see how it goes. We'll drop more. I haven't got any cutting oil. I got this stuff that I bought from Ackland Granger. That's Granger's up here, I believe, in Canada. I bought this while I was picking something up at one time. I don't know how good it is. This stuff here, I bought that at Fastenal, I believe it is. That's just the local town here, and it was about $9, I believe. Yeah, quite expensive really. It's more like a jelly, and I've tried that, but I'm a little bit leery because I noticed that after using it, or the first time I looked after using it, I looked at this, or maybe it's on here. No. I looked at the tool holder, and it was, it had been like attacked, discoloured, and I got an idea it was from that cutting fluid. So I don't think I want to use it, although it says it's good for everything. Refined and blended in St. Paul Drill Factory, St. Paul, Minnesota. Yeah. Okay, let's see what we got here. Let's see what happens. Yeah, no, it's not going to work. No. No. It's probably, yeah, it's moved the headstock back. Mind you, I'm never going to take a cut like that. I wish I could, but I can't. So, I've got that was a 90 thou cut that we took previous. I'm going to, okay, I'll take a 100 thou. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And we're a little bit closer in towards the chuck, so yeah, that's no good, that headstock going like that. I guess maybe it needs a stop behind it of some kind, like a bridge. Okay, let's see what happens now. Now that's not bad. That's 100 thou, and it's gone from 600 down to, at the moment, 480, 470, 480, 470, 80, 79, 70. It's up and down a little bit, but that's 100 thou. That's not bad. I mean, it's not, if it was free cut and steel, I'm pretty sure you could take a bigger cut, because it's more like a lead kind of free cutting, you know. This I don't think is, although it's nice, I don't think it's free cutting. I'm sure it isn't, but so it's not fast. It's not a fast procedure, but then again, there's a subscriber last night commented that he is only, well, I won't say capable. He finds that a 10 thou cut is about all he can do, or 10 thou, maybe a 20 thou cut, and he was quite surprised to see the effect of this. if you're gonna take 10 thou cuts on the same feed, it's going to take you quite a while to remove 100 thou. So I'm pretty sure this would be quicker than doing it that way. Of course you can put the speed up a bit maybe. That's doing fine. That's 480. So it's dropped about 100 RPM. So I'm beginning to wonder whether it isn't, the problem isn't the motor and the control so much as maybe the pulleys, the belt, I don't know. But as you can see, it's cutting nicely. They say that when you get down to the lower speeds on this unit here, that you get to a point where you have no torque. Yeah, that's not bad. Yeah, you get to the point where there is it stalls if you're too low on your RPM or cutting speed. So maybe my theory is right, that in lowering the speed on the pulleys allows this knob to increase further around the pot, and in so doing you gain more torque. I don't know, maybe somebody who's watching this can put me in the picture. I admit that I don't really know much about the electronics, so I could be just clutching at straws, I don't know. Anyway, the person, the viewer that commented about the amount of cut also asked me about the angles on my tool bits and so forth. Well, I don't follow the specs that are available in the books and so forth regarding the rake of the tool, the clearance angles, stuff like that. What I do is, let's see, here's a tool bit here, probably, that I round up. I have a pedestal grinder, an old pedestal grinder that runs in Babbitt bearings with a motor at the back, and it's very similar to this system here. 2 pillow blocks and Babbitt bearings. It's in the other room, and it's got I think the wheel is about 5 inches diameter now. Both wheels are about the same size. I presume they were 6 inch, but when I got it, they were obviously ground down. And so what I did was I did a drawing on draft site, and I drew up a 5 inch diameter circle, and then I came out from the center of that circle to one side and determined that that was the center line from the wheel, and I placed a plate, I screwed a plate, a large flat plate about 1/8, I think it is, thick. On the already tables that were there, they were little tiny little tables. And so I added these plates, bigger plates, which allowed me to place the tool bit on the plate. And the plate was raised up, I think it was about 3/16 above the centre of the wheel. And so what I do is I place the tool bit on the plate, on the table, and I grind into the wheel, and the size of the wheel and the height of the plate gives me approximately a 9-degree angle between the table and the radius of the wheel. So that's basically how I grind my tool bits. I grind all 3 faces usually like that, and it's so easy. And you can take the tool bit out and resharpen it just by placing it on there on the table and just touching up the 2 cutting faces, and putting it back in here just the same as I do with this one here. I took it out and I just placed it on this table, which is angled and adjustable. I can adjust the angle, and the face of the diamond wheel is a 1-inch face width, and I just place the tool bit on there and go in like that way and in like that way, and within a couple of touches I've got a nice sharp edge again. And I can also put a nice radius on the tip accordingly. So that is an explanation that I can give of how I grind my tools, and that's basically it. I've just actually ordered a couple of those cheap Chinese braze tipped tools, because I had these bolts that I bought for the versatile dividing head and the chucks, the shear line chucks, and it was tough material, and I was having a job with high speed, so I had a couple of these that I've hardly ever used, just ordinary turning tools I guess, and I very seldom use them, but I can sharpen them on the diamond wheel and just touch it a couple of times. You know, it doesn't take long, and boom, it's sharp again. So that is basically what I do, and I guess this part of the video is particularly for the viewer that commented about more interest in seeing the tools and the angles that I produce on my tool bits. I've got the drawing on the computer here. I'll take the camera over and see if I can get it let's see if I can get it. Hope you're able to see this. Okay, I'll try if I can get in a bit closer. So this gives you a general idea. I hope it's clear and you can get a good view. The writing at the top I've described